everyone. It's just gone 4 o'clock now. Well, it is in Ireland anyway. So I'm going to kick off this webinar. First of all, I'd like to welcome everybody. Today we have attendees from all over the globe, from every single continent. So you're very welcome, and thank you for joining us to automated distributed data centers with controllerless SDN and open networking together with our partners Pluribus Networks. My name is Ciara McCarthy. I'm the Global Marketing Director for EPS. This is the 7th episode in our It's Open Networking webinar series. So you can access all of our past webinars and sign up for future webinars on our website. So the URL is shown on the screen there. And for anybody who doesn't know us, I'll just give a quick intro. EPS Global is an open networking solutions provider, and we work with customers worldwide. You can source your entire network solution from us. That's the hardware and the software, so in one place, and save yourself time and money, not to mention the hassle of dealing with multiple vendors and different delivery schedules. We've 28 global locations, so we're never far away, and we carry stock and provide technical advice and support for your implementation, which Barry will touch on later. So I'd like to also introduce our speakers today. So our first speaker is Barry McGinley. Barry's our systems engineer for EMEA. He primarily works on proof of concepts for data center, service provider, and enterprise deployments, and he leads the adoption of new bare metal hardware for carrier and telecom solutions available from the Cord platform in the ONF to backhaul projects within the telecom infra project. He provides the first layer of tech support to our customers with an in-depth experience in the open networking landscape, covering all of the open source software and hardware options. Barry's based in Dublin, Ireland, and is the author of a popular tech blog on our website at epsglobal.com. He'd like me to add that he's also an avid Celtic supporter and enjoys a pint of Guinness. Joining us today also is Mike Capuano. Mike is the Chief Marketing Officer at Pluribus Networks. With over 25 years in networking, including Pluribus, Infinera, Cisco, and Juniper networks, he has broad expertise across service provider and enterprise network architectures and technologies, including data center, edge, cloud, SDN, NFV, routing, switching, and optical transport. Mike is based in California, and we're delighted to welcome him today as a guest speaker. So finally, just a little bit of housekeeping. If you have any questions, just type them into the Q&A window at the bottom of Zoom. Barry and Mike will answer those questions at the end. And if there's any questions that we don't have time to get to, we'll answer offline directly with you. So with that, I will hand you over to the interesting people. Barry, I will hand over to you.
Cheers, Ciara. Thank you. And thanks, Celtic, got to mention. That's great. So as Ciara mentioned, I'm Barry McGinley, based in Dublin, and primarily working in open networking for EPS Global. So what we're going to cover today, I'm going to have a look at open networking, have a general overview of open networking. I'll have a kind of high level overview of an underlay and overlay fabrics and multi-site fabrics then as well. Mike will take us through private cloud trends, and then we'll have a look at the adaptive cloud fabric. So the controllerless SDN for multi-site. We'll summarize, and then we'll take questions at the end. So we have a bit to get through, so I'm going to push on. Okay, so Ciara touched on EPS and what we actually do in open networking. So we're around 21 years, but since 2013, we have been distributors for edge core networks. So that was our entry into open networking. But I think we realized pretty quickly in 2013 that the normal rules of distribution weren't going to apply here, and it was kind of twofold. So 2013, it was only hyperscalers that were deploying open networking. And then as well, hardware is only one part of the puzzle. So we had to go out and start talking to the software vendors, and not just some of the software vendors, all of the software vendors. We like to say that we're vendor agnostic when it comes to the software, so that we're not kind of pigeonholing a piece of software in where another one would do a better job. So we'd like to kind of simplify open networking for our customers. So I suppose looking in, open networking can be a bit daunting. So you might have 6 different operating systems, 6 different hardware vendors. You have hardware interoperability or hardware compatibility lists from the software side. You have interoperable optics, and so on and so forth. So it can be a little confusing. So we try to take that hassle away for our customers. We'll put on the operating systems, the licensing, bundle in transceivers. So basically switches are ready to slide into a rack. We also provide this service for our our software vendor partners as well. So we can decal boxes with stickers and labeling. And again, stick the NOS on, stick the licensing on, bundle in transceivers. So basically the switch is ready to slide into a rack when it arrives in the DC, which does take some of the hassle out of open networking. Okay, so open networking attributes and benefits. So most of you guys are going to know this stuff. So on the attribute side, we've open hardware. So we've white box, bare metal, and bright box. Bare metal is our bare metal box, and it has a bootloader called ONI on it, which allows us to put the NOSes on. We then have white box, which is a bare metal switch with an operating system on it. And then we have bright box, which is basically a bare metal switch with a different label on it. So that would be HP and Dell and companies like that. We have our open software. So we have open source and we have commercial. So Pluribus would be a commercial software offering. And then we have software controlled infrastructure, SDN, network function virtualization, automation, analytics, and so on. And that's more about what we're going to talk about today when we look at the adaptive cloud fabric. So the benefits, so the main benefit, first benefit, I should say, is disaggregation. So removing vendor lock-in is important. Now we have a choice of the software and we have a choice of which hardware we put it on. We've greater control over our network infrastructure using SDN. So by the separation of the control and data planes, we can control our infrastructure much better. Rapid innovation through an ever-growing community, and that's kind of twofold. So that's people who have implemented open networking in their data center, and then also the kind of organizations that run open networking. So we have the Linux Foundation, the OCP, look after the hardware side. We have the ONF, the Open Networking Foundation, and we have the Telecom Infra Project. And both of them are kind of looking at the carrier and telco markets. Reduce CapEx and OpEx. So CapEx, obviously on bare metal, we're going to reduce our capital expenditure. And then when we move into the SDN side of things, we'll see how our operational expenditure will decrease. So the physical side of things, so merchant silicon is very important to bare metal. This is our switching ASIC, and we have Broadcom, Marvell, Mellanox, Cavium, and Tofino. Broadcom with the highest market share at somewhere between 76 and 90%. So anyway, a monster in the merchant silicon world. Multiple bare metal vendors. So we have EdgeCore Networks, Quanta, Delta, UfiSpace, Celestica, and these companies are primarily out of Taiwan. EdgeCore Networks is the leader in the bare metal switching world. The main switch has been sold today for data centers. We've 10, 25, and 100 gig. 40 gig was kind of skipped a little bit. People seem to move straight to 100 gig. So Trident 2 and 3 for our leaf switches, and then Tomahawk 2 and 3 for our spine and super spines. And they are Broadcom merchant silicon. We moved into the telecom space since 2016. So there's two organizations there. So the ONF, the Open Networking Foundation, started a project called CORD, which is Central Office Re-architected as a data center. And then the Telecom Infra project again started in 2016. So there's 3 different project groups. They have one for access, so it's your RAN, then backhaul, which is from your cell tower back to your data center, and then core and services. So between the two of them, they have a bunch of projects that have reference designs and actually are in production networks now. SIBA, software-enabled broadband access. I think Turk Telekom and Deutsche Telekom have implemented that. Trellis is spine and leaf, so like a fabric within the central office. Comcast have that in their production network. And then we have OOPT, which is the Open Optical and Packet Transport, similar to ODTN that the ONF run. And that's the white box Cassini transponder from EdgeCore for backhaul. And that's actually implemented in a bunch of different networks. Again, Broadcom are kind of big in this space as well. So the chips I mentioned, Trident 2 and 3 and Tomahawk 2 and 3 are from the XGS chipset, but they released the DNX chipset, which some of them are called Qumran AX, Qumran MX, Jericho and Jericho 2, and Ramon, and they've been very successful in that telecom space. So just a quick graph for you. This is from Omdia's Data Center Network quarterly call, just to give you an idea of bare metal and where it's going. So I think we're around here now. So we're just about 30% of all ports shipped. But then you have to take the the bright boxes into the equation there as well. So when we do, we're actually up over kind of closer towards the 60% mark of ports shipped. And one of the other important parts there is the maturity and availability of options for switch NOSes continues to improve. So that is quite important. So on the telco side, it seems like nearly once a month now there's a new NOS coming out that may have been in the middle of a proof of concept for a year, 16 months with a tier 1 telco. But then the maturity side is really important for the data center. So Pluribus are 10 years old now, have over 300 large implementations worldwide. Cumulus are over 10 years old. IPI are 20 years old. IP Infusion, Pika 8 are more than a decade old. So they're not new companies and they're not startups anymore, which kind of helps assuage anybody's worries, I suppose. So very briefly, I'm going to go over underlay, overlay, and fabrics because it'll help us when we get to looking at the adaptive cloud fabric. So the underlay basically is the actual physical devices. So our switches and routers. So here are switches, routers, and cables is our underlay. IP connectivity is done through layer 3 protocols. So BGP, eGRIP, OSPF, so on. It's responsible for delivery of packets. And the underlay is hardware orchestrated. And now the overlay that we're going to look at is software orchestrated or virtualized. So the overlay sits above the underlay. So this is our underlay here. And our overlay is the virtual network formed on top of our underlay. And the way it kind of works, this is quite a high level overview now. So say we've two switches, say we've that switch to that switch. We have on the switch ports are called VXLAN tunnel endpoints, so VTEPs. There's, oh, sorry, go back there. So there's one at one end and one at the other end. One does the encapsulation and one does the de-encapsulation at the other end. Each VXLAN network is given a VNI, which is a VXLAN network identifier. It's similar to a VLAN identifier. So with VLANs, we had 4,095 possibilities. With VXLAN, it's 24-bit. We have 16.7 million possibilities. So you're not going to run out. So you can imagine with VLAN, you have 500 companies, say you can give them eight VLANs each before you run out. So the packets then are transmitted, encapsulated with the VTEP, sent over the VXLAN tunnel, and de-encapsulated with the other VTEP. Multiple overlays can run through the same underlay for multi-tenancy, and that's quite important when we look at multi-site. Okay, so very briefly, we'll look at fabrics. So we've got 4 spine switches here, and we've got the pole just popped up there. We've got 48 leaf switches. So each leaf switch attaches to a spine switch, and it kind of forms this woven crisscross pattern. This is where we get the name fabric from. And why do we require fabrics, or where do they come from? So the proliferation of east-west traffic, basically. So before, when we used the 3-tier hierarchical model, we had a core, a distribution layer, and an access layer, and traffic was coming in our core, down to a host, and back up out the core. That's not the way traffic is moving anymore. So traffic is moving more around the data center. So east-west traffic from node to node. VM, we need it for VM migration and containerization requirements. So allocating resource to spin up containers quickly. And then what we're going to look at actually, the ability to create one logical data center over multiple sites, which is what we're going to look at when we look at the adaptive cloud fabric. So the benefits, we have scalability. So if we're oversubscribed, we add a spine switch. If we need more port density, we add a leaf switch. Really simple. More effective load balancing. So each leaf switch can go to any of the spine switches. The network's more easily segmented, which improves security. Network resiliency is improved. When we look at leaf switches, if one fails, we're not in any danger. And on the automation side, there's a couple of different ways of doing this. So we have scripting, so using Ansible, Chef, or Puppet to push scripts. That's still done on individual devices though, or else we can look at the SDN way of doing it, and that's what we're going to be looking at when we look at the adaptive cloud fabric. Hold on. Okay, so multi-site fabrics. I'll be very quick here because I think I've gone over. So we've 3 data centers here, and traditionally data center interconnect would get us to the border leaf switch. So even if we did have a fabric, we have a fabric in each one of the data centers, not a multi-site fabric, and that's where Adaptive Cloud Fabric comes in. It's a controllerless solution. Having a controller brings in its own issues, which we'll look at. Single point of failure, obviously costs. You would have to have 3 controllers in each one of these data centers. Business continuity and disaster recovery strategies get simplified. Resource utilization is far better when you think you can actually pool your resources between the 3 data centers and you're not doing it individually. And then obviously workloads can be migrated from data center to data center as there is no boundaries. So Mr. Green here can work here, he can work here, and he can work here just as easily and move his workloads around as he sees fit. So that leads us into Mike going to tell us about the Adaptive Cloud Fabric.
All right, well, thanks for having me. Just a comment on the poll. That was pretty interesting. The 2 lead sort of answers were, the 2 lead answers were, I'm investigating VXLAN, and I'm planning on deploying VXLAN overlay in the next 12 months. So that's good. Kind of makes sense, kind of what you'd expect. Great. All right, so let me talk about some cloud trends, what we're seeing in the market, what we've heard from some analysts that we engage with. So this slide is from IDC. It's a survey they do kind of every 18 months. And it fundamentally shows that, there's certainly lots of workloads moving into the public cloud, and there's, some anecdotal evidence that that's accelerating with COVID. But the majority of workloads do seem to be staying in private infrastructure versus public clouds for many reasons. One is greater control, another is security concerns, a third, data sovereignty, privacy, lower cost, managing costs if you don't have bursty workloads, and then avoiding lock into one cloud. So this shows that approximately 75% of workloads are staying private. Even if it's off by, 20 points, let's say it's 50 or 60%, the fundamental message is the private cloud or your data center is here to stay, whether it's on your premise or in a colo, or even being hosted by a non-hyperscaler, and that infrastructure needs to be cloudified effectively. And that's kind of the key message. The second trend we're seeing is actually an increasing number of data center sites. So there's sort of a trend of consolidation, right, to try to get data centers more organized, but there's also a trend of distribution. We're seeing enterprises and institutions embrace active-active architecture, so that's starting to become more and more important, and I'll talk about that on my next slide. Increased use of colocation, managed private cloud. Acquisitions are happening where you're adding a data center or 2 because you acquire another company. Deploying new applications that require better user experiences, lower latency, like IoT, AI, ML, and that's kind of driving edge. And basically, this relates to the chart on the side, another IDC survey that shows, blue was when the survey was done and orange was, plus 2 years. You can see the biggest decline is in terms of folks who own 2 to 3 data centers who've got or deployed 2 to 3 data centers, and the increases are 4 to 9, 10 to 19, 20 to 74. So we're seeing an increasing distribution across the board. On the other side, you've got cloud service providers who service these enterprises, and they're looking at adding new regional and edge locations to meet customer requirements for low latency, interconnection, data sovereignty, and also edge computing. So that's the second trend, just this sort of distribution of data center sites. If I double click on the first topic, on the left here, I've got some information from Forrester. And the question in this survey was, what was the cause of your significant disaster declaration or major business disruption? So they basically did a survey. They found 40 leading IT groups that had to deal with a data center failure and having to move over to a backup data center. Technology failure was number one, and interestingly, cyber attacks, ransomware was number two, power failure, network failure. So that's, that kind of downtime is extremely expensive, and why we're seeing a move to active-active. And the VXLAN overlay fabric can really simplify and make that super easy. And it can either be full active-active, or it can be active hot standby, where you just have to reconfigure the IP on the firewall, and all the rest of the network just moves automatically. You also get other benefits, which I'll talk about, from a VXLAN overlay fabric and unifying multi-site data centers, agile service delivery. You can have any workload, any resource, any site, OpEx savings. You're managing 2, 3, 4, 5 data centers as if it's one single data center, with remote management, particularly important in the time of COVID-19. You can move workloads super easy. And then CapEx savings. So because you can share resources as if it's one pool of resource, you can really optimize capacity utilization and resource sharing. So it's a great way to kind of truly optimize your investment in your multi-site data center. Now, if I look more from an edge perspective, whether this is enterprise or a cloud service provider, we're seeing edge deployments accelerate. It's a major trend due to 5G, but also independent of 5G. This is for latency, lower latency applications that require sub 20 millisecond response times, thinning of bandwidth at the edge. If you have, say, thousands of video cameras, you don't want to take those all the way back to some central site. You'd rather just process the video you need. Autonomy, data sovereignty, and privacy. And we're seeing data that shows 50% of Euro cloud deployments are going to include edge computing, and 25% of IoT infrastructure investment will be in edge computing. And as you get these more distributed sites, they're going to be smaller. So you really need a solution that gives you the lowest cost, the least space, the lowest power, and are really, really optimized for these kind of constrained sites. And you also really need complete automation, right? You're going to have lights out locations, or you're going to have locations where there's no technical network operations team or data center infrastructure team co-located, and you just don't want people in cars driving around to go troubleshoot a problem. And then you need complete visibility at all times. So those are some of what we're seeing with edge and some of the requirements. So the fundamental question is, data centers are, data center architectures are becoming more distributed, and they must evolve. With this increasing distribution equals increasing complexity and operational challenges. Like I mentioned, remote sites with no co-located NetOps, more points of entry and exploitation for bad actors. So how do you build this distributed multi-site DC that's automated and cost-effective and agile and simple to operate? That's the fundamental question. And that's what I'll talk about on the next slide. So let's jump into controllerless SDN for multi-site data center fabrics. So just a reminder, Barry talked about, you've got your underlay network, and then you've got your overlay network. And there's different ways to automate and build these things. And that's what I'd like to talk about on the next slide. The beauty of the overlay network is you're fundamentally instantiating services in software. You can think of the overlay as like this beautiful coating of snow over a bit of a heterogeneous physical network. And it allows you to be, really agile effectively. So I'm going to talk about 3 different approaches to building and automating overlay and underlay. So I've got the approach on the left. I've got the open networking version. Open networking means I'm deploying an operating system. If I don't like it, I can replace it with another operating system. If I don't like the hardware, I can replace it with another piece of hardware. Then we've got our vertically integrated solutions, which means the software and the hardware are bundled together. And, once you deploy that, that's what you get. You deploy Cisco, you're on Cisco. You deploy Cumulus Mellanox, you're on Cumulus Mellanox. And then the pros and cons. So the first one is switch-based overlay. So that means I'm terminating the tunnels on the switch, like Barry talked about earlier. And you can do this with BGP EVPN. And we put a DIY in front of that because it really is do it yourself. The pro of this is you don't need to pay for SDN functionality. This can be a very cost-effective approach. The con is there's no automation. So you've got to configure the underlay box by box. You've got to configure the overlay box by box. So it requires a well-resourced IT team. They have to be able to do scripting and programming. And, some folks like that. That's what they like about being in this field, and that's fine. Or you might decide to pay for a third-party automation solution like Apstra. Apstra is kind of a network management automation solution, but they've got to keep synced with multiple vendors. So they've got, it's a pretty small company that has a lot of work to do to kind of stay up with all the releases from the different vendors. So another solution is SDN, and that's primarily what we're focused on today. So the tunnels terminate on the switch, but it's SDN automated. And then in the open networking category, really Pluribus is the only one. We used to have Big Switch. They did underlay automation only. Pluribus does underlay and overlay automation. And then you've got Cisco ACI. So, in this big matrix, we're kind of closest to our philosophy with Cisco ACI. The pro for this is it radically simplifies fabric network operations. It integrates the underlay and the overlay. It works out of the box. The con is there is a slight charge for SDN with Pluribus, or a significant charge for SDN with Cisco. Proprietary solutions can be really expensive, but you can save on the OpEx side because it's so simple. With Pluribus, for example, you can deploy a service across the fabric with one command. You can deploy the fabric with 2 commands. With BGP EVPN, it takes 832 commands to do a 32 switch fabric for one service. So that's just, just kind of keep that in mind. And then the last one is a compute-based overlay. And this is SDN automated at the overlay, and the underlay is typically separate, and the underlay can be SDN automated or not. So focusing on the overlay, these are solutions like VMware NSX, Juniper Contrail, Nokia Nuage, and there's some others. The pro to this is you do get finer grained network segmentation because you're terminating the tunnels on the host. So you can kind of go down to the VM level. But you have to pay per host licensing. It's really expensive, literally like thousands of dollars per host. You can't really aggregate non-server based devices into network segments. So if you're using network segmentation, you can't really aggregate wiring closet switches or IoT gateways. And you can aggregate bare metal switches with some of the solutions, but you've got to have a pretty beefy switch. You got to run an agent on the switch. It's pretty complicated. So there's a lot of integration and complexity. It requires separate management of the underlay. Application team, not the NetOps team. So, if that's the architecture that you want from an organization perspective, it could be a good fit. We believe the best solution on this page is Pluribus Networks, obviously, a little biased, but I'm going to take you through, why we think this is a great solution. So what I'm going to do first is, admittedly, this is kind of worst case, but I want to take a look at what a potential automation scenario looks like where you're using the compute-based overlay with an SDN underlay. The issue with this, with most of these solutions, actually all the solutions on that previous page, is they're primarily built for large single site data centers. So you start with your white box switch on the left. You've got your layer 2, layer 3 NOS, your basic NOS. Then you have an underlay control layer. So that typically requires 3 servers as an industry best practice for resiliency at every site. You think, big switch, this is effectively the way they worked. And then you've got your network overlay. So again, like a VMware NSX, you're going to have a bunch of NSX controllers at every site. And then you need your visibility. So you've got taps and probes and packet brokers at every site. And then you've got a stack of analytics servers like Cisco Tetration somewhere. Not typically at every site, but you've got, that's part of the bill of materials. And so, what Pluribus did when we were founded, the engineering team was very savvy in terms of distributed compute, database clusters and that sort of thing. And they said, hey, we're deploying these switches anyway, right? And actually, they're pretty powerful. They've got a multi-core Intel CPU. They've got RAM. They've got SSD. They've got a packet processing chip to help offload, some of the heavy network processing. Can we write some clever software that'll just use these switches we're deploying anyway as a distributed compute platform? And the answer is yes. And that's basically what the Pluribus founding team did, is they created effectively a protocol-free fabric. It leverages standard underlay protocols, both in the control plane and the data plane. It leverages standard data plane protocols, VXLAN, and the overlay, but it has a unique control plane for the overlay and for the automation of the underlay fabric that runs in the switches as if it's a distributed compute platform. So there's no extra controller hardware, no extra software licenses. It eliminates integration complexity because underlay and overlay are just integrated and it just works out of the box. You get a single point of control and a single pane of glass for management, whether it's a single data site or multi-site data center architecture. It's highly resilient because unlike controller-based solutions that use out-of-band management, have a fragile out-of-band management link and a single out-of-band management port on each switch, this solution can use in-band communication for the control plane. Because of the architecture using standard protocols in the underlay, it's simple to insert from a brownfield perspective. It interoperates at the overlay as well with VXLAN and EVPN. Integrated pervasive telemetry because of the architecture, every flow, and simplified network virtualization and segmentation for security. So it's a really powerful, extremely elegant, and cost-effective solution. So let's just do some visuals. So here's a single site data center. You've got your leaf and spine. You've got your underlay controller cluster. Again, 3 controllers is the best practice for resiliency. You got your overlay controller cluster. You've got your packet broker, your taps. You've got, if in this case, an orchestrator, so a Vim controller cluster, say it's vCenter. When you deploy a controllerless solution, most of that goes away. So if you have an orchestrator, you still have that, but everything else is embedded in the switch, in the leaf switch layer. That is where the fabric lives. And then over here on the right-hand side, you can see that I've got an optional Unum fabric manager. So that's an optional, basically a graphical view into the fabric that automates work, makes it even easier to automate workflows and drill into more data. But now let's take a look at what it looks like in a multi-site. So you get in a multi-site and you look at, say, Cisco ACI. They need 3 APIC controllers at every site. They need a multi-site director, or in this case, we're showing a big, where you got big switch doing the underlay controller cluster, and say NSX with the overlay controller cluster. You end up, and you're getting a lot of times to smaller sites, you end up with a lot of effectively non-revenue generating servers, a lot of overhead to do this automation. And then you kind of wonder, is it worth it, right? But with a controllerless approach, it's much more elegant. It all goes away. The fabric stretches across multi-sites seamlessly. it allows you, if you have an orchestrator, to have a single Vim orchestrator that stretches across those sites. And then again, if you want the optional Unum Fabric Manager and Insight Analytics, it stretches across the sites. So all of a sudden, all of that expense, integration, power, space goes away, and you've got a nice, elegant solution to automate the underlay and the overlay. So let me double click a little bit more on how it works. So fundamentally, as I showed you, the essence of what we do is contained within this Linux-based NetVisor 1 operating system. So open source, can be loaded with ONI, can be unloaded with ONI if you want to replace it. And then we have a Fabric license which activates this adaptive cloud fabric, and that is fundamentally what gives you this SDN control of the underlay and the overlay. So what happens is you deploy a number of switches. All the switches federate into a management fabric with a single point of control. So you just need basic layer 3 connectivity. So if you got 32 switches, now they're all federated together. They're communicating with each other. They're aware of the state of all the other switches. Then you deploy in an automated fashion the underlay. So layer 3 using BGP unnumbered. Few clicks. We've got a video that shows a 10 switch fabric being deployed in 15 minutes. And then you leverage the SDN control to do the overlay. So auto tunnels, the fabric automatically creates VXLAN tunnels for the overlay. VNI, VTEP mapping across the fabric happens automatically. And then now you have fabric-wide object automation. So in our case, in the Pluribus case, the services are delivered from the overlay. You can instantiate a VLAN, and if you can do it with fabric, you can say scope local, which is per switch, scope cluster, which is for a pair of switches in a cluster, or scope fabric, which means deployed across all the fabrics across all the sites. So I want to instantiate a VLAN everywhere, one command. I want to add a security policy, one command. It's really powerful. And then the essence of the way this works is it's a simple, high-performance, protocol-free fabric. So this gives us tremendous scale and allows us to do all the things we do because we're not loading the switch with heavy control plane protocols like PIM or EVPN, BGP inside the fabric. So it's a protocol-free fabric, and that makes it super scalable and allows it to be as elegant as it is. So let's take a look at a little bit more of an example. So in this case, I've got a multi-site data center. I've got 4 data centers. I've got a single point of control, and I put some of the tools that we can use over here, Unum or OpenStack or vCenter or Ansible, REST API, CLI, whatever. Single point of control can go into any switch. Typically, customers will pick a seed switch and a backup seed switch, and that's the kind of the entry point or the control point of the fabric. But fundamentally, you now have control of the entire fabric from that one location, and it really simplifies IT workflows. So all the way across the fabric, you automate edge port provisioning, so that's at the underlay. You automate overlay provisioning, like I mentioned. You automate network changes. If you're using OpenStack, for example, you spin up a VM, it will automatically program the network in the overlay for that VM where it's located. It simplifies IT workflows and just dramatically boosts productivity. So fundamentally, the IT team is now focusing on strategic issues instead of doing box by box configuration. Now, no matter how much we love it, we all know there's a lot of value in that. So I'll touch on a couple of other attributes which are important relative to the fabric. So the first is multi-tenancy, segmentation and slicing. So we have fabric-wide slicing segmentation across data control and management planes. So we have something called VNets, virtual networks, that if you really want to create a multi-tenant network, if you're a cloud service provider, for example, you can create an isolated network where each user has control of their own slice with whatever tools they want. In a single tenant network or within each of these multi-tenant networks, you can segment the network using distributed VRFs running on top of these VXLANs. And that creates security for lateral movement. So if someone penetrates the firewall for a particular tenant, the network segmentation will help, at a minimum, slow down the attacker or stop them from moving from one segment to another. So that's a powerful tool. We have a lot of customers who've deployed this to separate IoT traffic and IoT data and control traffic from their corporate network to make sure that that attack surface is separated. And then integrated fabric-wide flow telemetry. So the beauty of this implementation is we can see literally everything, every flow, every port, every connected device. And we have the ability to store that a little bit on the box and a lot of it off of the box, off of the switch, in the order of billions of flows. And you can quickly search and analyze those flows using our Insight Analytics tool. Again, this is an optional tool, but we have some customers who deployed us just because of this tool, because it's so powerful. You can drill down to a flow using powerful search at some point in time and very quickly root cause a problem. So this is extremely powerful. It's gravy or icing, but it's really powerful. So let me just touch on a couple of case studies, and then I'll hand it back to Barry. So this is a mid-market customer that has a pretty nifty deployment in Italy. 700 employees, company's called Scavallini. And effectively, you can see on the left, they've got data center 1 and data center 2. So they leverage the adaptive cloud fabric to build an active data center to increase resiliency. And then, one of the interesting attributes of the implementation of, or the Pluribus adaptive cloud fabric is it's not limited to a leaf spine architecture. It's very flexible. So in this case, they actually use the spine switches to also be the core, the campus core. And then off of the campus core portion of these switches, they hung some campus aggregation switches, and they leveraged the Pluribus capability to do network segmentation. So they're aggregating wiring closet switches, and then they're aggregating IoT, from their manufacturing facilities, IoT data from Siemens gateways, and they keep that on a separate slice to keep it isolated from the corporate traffic, like I mentioned. And fundamentally, that gives them fabric-wide automated service provisioning, flexible topology, like I mentioned, complete security from a network segmentation perspective, high resiliency, and it's interoperable. So it works with VMware vCenter. We have an integration with that solution, and it works with the Cisco access switches because we use standard underlay protocols. So pretty interesting deployment, and we've seen a number of these kind of deployments that extend past the data center. And then my last slide is a cloud service provider. So this is a company called Econocom. They're throughout Europe. They do about 3 billion revenue a year. This deployment's in Italy, and that group does around 600 million euros, I think. They had 4 data centers, and they deployed Pluribus, in this case, in the leaf and spine. And they leverage the integration both with vCenter and with OpenStack. And they only have, one set of Vim controllers, like I talked about before, which stretches across the data centers, which saves them a lot of money and makes their operations much more simple. And then also one other thing up here, Pluribus has, cloud service providers often have these DC gateways that provide interconnection to the public cloud. They can be pretty expensive edge routers like ASRs or MX. So Pluribus actually it has built a white box version of that Econocom has, that allows the interconnection, the on-ramp to Google, Azure, AWS, Oracle. And then more recently, we've actually integrated that functionality right into the top of rack border leaf switch. So in an edge deployment, if you need interconnection like that, you can actually have that built right in, further reducing power space that's required for these smaller edge deployments. So multi-site data, 4 data centers, stretched vCenter and OpenStack, any cloud, any service. So this is a really powerful regional cloud platform for Italian customers who care about data sovereignty, but also want to interconnect to the public cloud. And they leverage our multi-tenant capabilities, obviously, because they're serving a number of customers. So both of these customers, Scavellini and Econocom, coincidentally happened to be in Italy, but they were, are both very, very happy and good examples. And Barry, I'll hand it back to you now.
Cheers, Mike. Thanks for that. That was excellent. Okay, just a quick summary. So EPS can be your kind of single point of contact for all your open networking needs. We have the relationships with the hardware guys, we have the relationship with the software guys, and we have the in-house technical kind of knowledge. On the hardware side, Edge Core can reduce your total cost of ownership by 40 to 60%. We've looked at how Pluribus's adaptive cloud fabric can give us comprehensive automation, secure network segmentation, and as well pervasive visibility and insight. As well, like, didn't even go into Pluribus have an adaptive monitoring fabric as well, which can give us even more. So some of the solutions: data center fabric, multi-site data center, I should say, multi-cloud, IoT video security, which was a good one Mike was explaining to me, which could be something good for the future, network segmentation, and their network packet broker and lab automation. Some of the blogs we have on the website. So there's stuff about all kinds of open networking. So on software, on hardware, containers, fabrics, telco, hardware and software as well. So that's it on the presentation. I think there is a few questions, Mike. Alessandro picked up a few of them as they were going. But I think we had
there is actually quite a few questions today. Alessandro picked a few of them up as we were going through, but I'll just, like, considering timing, I'll say the first two anyway. I think this one is for you, Mike. So other than cost savings, are there other benefits to a controllerless approach?
Well, first of all, let me thank Alessandro for being on the call. You know, as a CMO, it's always good to have deep technical backup. So thank you, Alessandro. Well, I think I covered it pretty well, but fundamentally, the savings first come from literally eliminating lots of physical hardware and lots of extra software licenses. So whether that's controllers and licenses for the underlay, controllers and licenses for the overlay, and then with compute-based overlay, you've got to pay per host license fees. That's one set of savings. Obviously, without all that stuff, you're saving power and space. That's going to end up saving money. But the biggest savings really is in OpEx. The automation of this sort of approach is phenomenal, and really can just let IT teams focus on more strategic issues if they're larger IT teams, or if it's a smaller IT team, it just makes their life easier. So they're not, up at all hours of the night doing box by box configuration and troubleshooting. It's all, through a single point of control. So that's the essence of it.
Okay, thanks, Mike. The next question is quite a big question, actually, Barry. This one is for you. What are the evolutionary trends in the data center, and how can you optimize on capital expenditure?
I suppose on the CapEx side is quite simple, bare metal, which we've been talking about. So not just bare metal on the switching side, on the server side as well. So we work with Lanner, obviously Supermicro and companies like that. But so that's a simple one. But then on the evolutionary trends, I suppose it's, I touched on it a little earlier actually when I said the maturity of the software for DCs. So this all kind of started, this open networking thing started back in about 2010 with Facebook redoing their entire data center basically. They built their own switches, they built their own servers, and built their own operating system, FBOSS. Microsoft went and did the same a couple of years later. Their operating system is Sonic. Obviously, companies can't do that themselves. Like, there is stuff there. So there's ONL, which is a foundation layer operating system, which you can build the features on top of. But the majority of enterprises aren't going to do that. So I think seeing the maturity of, say, Pluribus, IPI, Pika, and the top software vendors in the open networking space is really making a difference, I suppose. Definitely over the last 3 years, I've seen a massive change in customers. They've heard of the companies, and they know about open networking, and they know about bare metal. So it's not frightening anymore, I suppose.
Okay, thanks a million, Barry. And then just one last one. This is for either of you, I think. Do you see a difference for DCI versus multi-site data center fabric, and can Pluribus be used for both?
Do you want to take that, Mike?
You want to take it, or you want me to?
No, you go ahead.
Okay, sure. Yeah, no, there's definitely a difference. It's a really good question, actually. There's a lot of different definitions of data center interconnect. There's kind of the optical viewpoint, where I think the term has been used quite a bit. And then there's the higher layers. But effectively, when we think of pure DCI, we think of edge to edge, right? It's just the edges of the data center are connected with something. Pluribus actually has a number of deployments where on one side you've got, say, a Cisco Nexus data center. On the other side, you got a Cisco Nexus data center, and then they put Pluribus right at the edge to create a fabric that enables very simple workload migration. And that's what I consider DCI. What I consider data center unification is more about what we talked about today, where all of the leaf switches are running Pluribus. The spines don't have to, because the spines can be third party or they can be Pluribus, but all the leaf switches are running Pluribus. And then the fabric stretches down across and throughout the entire data center. And so you get the effect of DCI, but you really get the effect of a completely unified data center. So if you have like 5 data centers literally anywhere in the world, you can operate them like one data center. And that means you have very easy control, lower OpEx, unified policy. So you deploy a security policy, ACL or whatever, it is applied to every switch in the fabric, no matter where it is. And if it can't be applied to one switch in the fabric, an alert is raised. That config is not committed until that problem is resolved. So make sure you have a very consistent configuration throughout your multi-site data center network. It reduces human error, because you're doing everything from a single point. So the essence is unification. The fabric goes to all the leaves, data center interconnect. It's just at the edges. You can use Pluribus for both.
That's brilliant. Well answered. So I think that's all the questions for now. There is a good few more, actually, but we just don't have time to answer them right now. But what we'll do is we'll send follow-up emails to everybody. Let me just check that there isn't just a real quick one there. Yeah, someone has asked, can we share the PowerPoint file? That's absolutely no problem. We'll be sending the both the recording of this webinar along with the PowerPoint slides to you over the next couple of days. And then last question, can we access the recording later? Yeah, so we'll be sending you the slides, the recording, and we can answer any of the additional questions with follow-up emails. So with that, I'd like to thank Mike from Pluribus and Barry from EPS for being great speakers. And I'd also like to thank everybody who dialed in today, taking the time to join our webinar. And we will hopefully see you next time.
Thanks, Kira. Thanks, Mike.
Thank you. Great to be here.
Bye.